So here's 30 degrees. And at 60 degrees, what's going to happen is we kind of ended up having to flip-flop those coordinates because now the x-coordinate's the shorter length, and the y-coordinate's the square root 3 over 2. So we call this picture the unit circle. When you guys hear the word unit, big idea for the unit circle, unit is a word that derives from one. Think about how do you say one in Spanish?
Uno.
Uno. How do you say one in French? Un. Is everybody with me? Unit means one. And so the unit circle has a radius of 1. So last week we said, oh, the sine of an angle is the y-coordinate over the radius. If I do that on the unit circle and I know that r is equal to 1, what can I say about the sine? It's y over 1, which is just the y-coordinate. On the unit circle, the sine of an angle is just the y-coordinate. So if I asked you guys, hey, what is the sine of 60 degrees? If I go to 60 degrees, what's my y-coordinate? Square root 3 over 2. Done. The sine of 60 is square root 3 over 2. Yes? Cosine was x over r. But now, since the radius is always 1, that's just x, because x over 1 is x. Tangent is still going to be y over x. Now, every single one of these angles on this unit circle matches the angles we came up with yesterday. Okay? So when you think about what angle, if you look at this one, this angle right here is halfway between 60 and 30. What do you guys think that is? 45. And so we could go back and we could look at Now, we haven't done anything with axes yet. How many degrees is the x-axis right here before I rotate? 0 degrees. And guys, if the radius of this circle is 1, what are the coordinates of this point? The x-coordinate's 1. The y-coordinate is 0.
Square root is 0.
Are we feeling okay? All right. What about this point? Talk to me about this angle. What angle is this one?
90 degrees.
90 degrees. And its coordinates are?
Square root like 5 maybe?
Nope. Hey guys, what's the x-coordinate of this point? 0. You with me? The y-coordinate, if the radius is 1, is 1. Is everybody okay so far? So what is the cosine of 90 degrees? So cosine is x, right? 0. That's it. So the reason we like the unit circle is we can get the sine and the cosine and the tangent of things really, really fast. I lost my fidget. Everybody okay so far? Now, guys, do you need to have this circle memorized?
Yeah.
Probably not.
Your performance tasks, your graded assignments are all open note. Okay? We're going to fill this out together. I'm going to teach you the reasoning behind it. Do you have to memorize it? No. Do you have to be able to use it? Yes. Okay? All right. So, guys, what is this angle right here?
150. 110 maybe?
120. Now, Walter, you said 60. The reference angle, this one, is 60. The angle itself, remember, starts at that positive x-axis. Okay? Now, what are the coordinates here?
Negative 1/2.
The x-coordinate's negative 1/2.
Is the y square root of 3/2?
Yeah. I'm just reflecting this point. All I did was take this and say, hey, in order for it to be in the second quadrant, the x-coordinate would be negative. All right, what's the next angle?
Negative square root 2.
So the coordinate is negative square root 2, positive square root 2.
Is it 135?
It is 135 degrees. Here's how I know that. I can either say, oh, it's another 45 from the 90, or I could say, oh, it's 45 short from 180. Either way, if I do 90 plus 45 or 180 minus 45, I'm going to end up at 135. Okay? What about the next angle?
150.
Is 150. What are the coordinates?
Negative square root 3/2
Negative root 3 over 2
and 1/2.
and positive 1/2. Okay. This angle, 180.
Negative 1, 0.
Negative 1, 0. So far, does this feel manageable?
Yeah.
Kind of.
Okay, real quick, what is the cosine of 150 degrees? Negative square root 3 over 2. You just go to the x-coordinate of 150. Is it okay? Okay? So much fun.
No.
Absolutely.
Like, I'm not even trying to be anything. This just isn't going.
So is all of the points, like that's just the tangent? All of these?
We'll talk about tangent after we get the circle filled out. There's a reason I'm not giving you any tangents yet. It's one level beyond what you guys want to do. But it's not bad. It just, I want to develop some other stuff first.
Do we have to learn tangent?
Yeah.
Okay.
All right, so here's what I want you guys to do. I want you to try filling out the rest of the angles only. Don't worry about the coordinates, just fill out the angles. So The reference angles are always 30, 45, and 60. How'd I do?
I agree with it.
I would have to agree as well.
We got the same answer, so either we both got it wrong or we both got it right.
You both got it wrong.
It's possible. I've made all sorts of math mistakes today.
I just make math mistakes. It's not really like a quota.
Is that, 300, 315, 330?
Yep. And then go ahead and do just the third quadrant coordinates.
Oh my.
What do we know about the coordinates, the x coordinates in the third quadrant? They are
Negative,
negative. What about the y coordinates?
negative.
Negative. And square root 3 is bigger than 1. So like as I go to do this one, I know the x coordinate's the one with the square root 3 because the x coordinate's definitely bigger than the y coordinate.
I would agree with that.
You should.
What if I chose to disagree with that?
That's fine. You're entitled to your own opinion.
She said 3 over, or it's 3 squared, root 3 over 2 is bigger than 1.
Mhm.
Okay.
No, root 3 over 2 is bigger than 1/2.
Oh, okay.
Root 3 is bigger than 1, which is why root 3 over 2 is bigger than 1 over 2. Because they're both over 2. They're the same denominator. Because the denominators match, you can directly compare the numerators to each other. Okay. Hey, what do you guys think this coordinate is for the 270 degrees?
0, negative 1.
Yeah.
Either I'm looking at this wrong or you reverse the coordinates of 240. Shouldn't the root 3 be in front?
No. Because the y coordinate's bigger than the x coordinate, yeah?
That's how it is on the other ones too. I think it works.
Let's put it this way. These two are two different points. They cannot have the same coordinates.
And like this one up here has the same points, but positive, like for 1/2 at first.
So you can always go, like if I look at, like if I draw this up, right? This distance, Walter, if I draw this up, right? This distance versus this distance, this one's the bigger distance, yes? Root 3 is bigger than the 1. That's how, so like I know that the y coordinate is the bigger of the two, which is the root 3.
Yeah, I just wrote it wrong.
All right. And then let's just finish out our coordinates. So let's see. Notice that now my x coordinates are positive and my y coordinates are negative. All right. How are we feeling so far?
Can you zoom in? Can you zoom in on the bottom?
There's only one thing I'm going to do to make this worse.
What is that?
We're almost done. We're almost done. I swear. The coordinates are usually the part that kids hate the most. Oh, it's a toss-up. Hey guys, what's the cosine of 300?
1/2.
1/2. Because cosine is x, so I go to 300. I go to 300, and then I say the x coordinate's 1/2, so I know the cosine of 300. Okay. There's one more thing we're going to do in creating the unit circle, and then we will take a little bit of a break.
Is that the blank spots left?
It's the blank spots that are left.
Oh, that seems kind of scary.
Are we doing like measure of like the outside line?
Is that
Well-
how many radians?
Yeah, we're going to put the radian measurements next to each of the
Thingies.
degree measurements. Degree measurements, yeah. How many radians is 0 degrees?
0?
0.
If it was like more than 0, I was gonna be confused.
But it's not, so we're okay.
Yeah.
All right, y'all. In general, radians.
They're scary.
They are scary.
Aren't they like 6.25 or something?
6.28.
Right up there.
All the way around the circle. So 360 degrees is 6.28, but we always leave our answers in terms of pi. So in fact, that 360 degrees is 2 pi radians. So all the way around is 2 pi. So let's think this through for a second. The 180 is half a way around. So it's half of 2 pi. So how many radians is the 180?
1
Pi.
So it just,
Like pi.
What about 90?
Half a pi?
Pi over 2. What about 270?
2 pi? Or
1.2 pi?
1 pi. Pi over 3.
2 pi, wait, 2 pi over 2 is just pi.
3
All right.
for 2 pi.
3 pi over 2. In some respects. 0. 1/2. 2 halves. 3 halves. 4 halves. Is that okay?
Yeah.
Kind of.
Yeah, that can work.
We have to figure out what's in between.
I just want to disagree for the sake of disagreeing.
That doesn't sound like you at all.
I know. This is a whole new concept.
Walter's never done that before.
It's okay to try new things.
It's okay to be different. Just sometimes it's wrong.
Be you won't.
Yeah.
Or we need to make kids conform to the standards.
All right. Are you guys with me? That the 45 degrees is halfway to the pi over 2.
Oh yeah, that makes sense.
That
What's half of half?
0.25.
4.
Pi 1/4. So this is pi over 4.
You know, that makes sense.
I was trying to make sense today. It literally is my goal to make sense.
I would really hope so.
Wouldn't that be your goal every day?
No, some days she likes throwing the kids off.
I mean, I don't want to say that sometimes it's my goal to throw you guys off. However,
When it comes to making
there are
these questions.
times where I think when students struggle, they learn more. And so the long-term benefit of providing things that only sort of make sense for you guys is actually pretty good. Yes?
Wouldn't 135 be 3 pi over 4?
Yeah, so now let's start counting fractions again. 1/4, 2/4,
3/4.
3/4. This pi would be 4/4, right? What do you guys think this one is?
6/4.
5 pi over 4. Okay, and then if I go here,
6 pi?
6 pi over 4. Are you guys cool with 6 over 4 equals 3 over 2?
Yes, because it lines up with all the other ones, even though it could simplify.
Like if I simplified 6 pi over 4, wouldn't 6 over 4 become 3 over 2?
Yeah.
Okay. 6/4. 7/4. So, what's worth noting?
Scary.
All the over 4s are 45-degree angles.
They go up by 2 every time, it seems.
Almost done. Hey guys, what is the sine of 5 pi over 4?
Negative 2 over 2.
Negative root 2 over 2. Done.
Would for the ones between the 45-degree angle, so the 30-degree angle, would we just split it in half again?
You guys tell me. Is this angle half of this one?
No, that's like 2/3.
2/3, yeah. It gets a little hairy. So, different question. I could take the pi over 2 and divide it by 3, right? How many 30-degree angles fit inside the 180? 6, right?
That is seconds.
So, could I just call this pi 1/6 then?
I can agree with that.
1/6? So what does that make the 60 degrees? 2 pi over 6. But instead of 2 over 6, you know what we're going to do? What do we know about 2 over 6?
1/3.
It's 1/3. Let's see. So we got 1/6, 2/6, 3/6. Does that fit for the 1/2?
Yeah.
Does 3 over 6? Yeah. 4/6 would be, well, what's 4 over 6? 2/3. Four sixths and then 5/6. Six over 6, which fits. 7/6 doesn't reduce. 8 over 6. 4/3, yeah. 8/6. 9 over 6 does in fact reduce down to 3/2. Okay. 10 over 6.
5/6.
5/3.
Yeah.
And then one more.
Something. 11/6.
11 pi over 6. Are we feeling okay so far?
Okay, it's okay. Like, on the scale of 1 to 10,
On a scale of 1 to 10, where are you?
I mean, what would you call okay? That was it.
I feel like a 5 is like a solid, like 4 to 6, like that area is like okay.
4 to 6 is okay. 7 to 8 is like, I'm alright. I'm good.
And
9 to 10 is I'm great.
then like anything below the 4 is like, ooh.
4.732, I'll take it. I'll take it for the first time I've ever seen the unit circle. 4.73 is awesome. In my head, that's good. For the first time? Okay.
Say you're gonna, in my mind, how are the coordinates working?
So if you think about the pictures we drew yesterday.
I was not here yesterday.
Oh, yeah. You should watch the video from yesterday. I think it'll make a lot of things make more sense. And it is up in Schoology. But the basic premise is okay. Next. Or we're going to take 2 small breaks instead of 1 big break. Okay, so let's take like 3 or 4 minutes. Or you can take a break, get up, stretch your legs if you need to. And like, so maybe 10 and wait. So I go to pi radians, and I say, what is the x coordinate at -1? The x coordinate is -1, so the cosine of pi is -1. All right. Now, tangent takes a little bit more. Not a lot of it, a little bit more. So guys, tangent of 135. 135 is here, yeah? So I'm going to take the y coordinate over the x coordinate. And when we first look at this, it's going to feel real icky. So my y coordinate's √2/2. Over my x coordinate is -√2/2.
This is too scary for me.
And what happens is we start to see those fractions over fractions, we feel really icky about it.
You cry and crawl to a ball.
Try not to cry a lot.
Guys, hey, stop.
Stop stopping.
Don't touch your calculators. Hey guys, what's 3/3?
1.
What's -3/3?
Is it negative?
-1. What's -5/5? 1. What's 6/6?
-1.
All right, do you guys see that the top and the bottom are the same number here?
Yes.
It's too late, I've already cried.
So what is the tangent of 135?
1.
It's -1, because we've got 1 positive, 1 negative. But they're the same thing.
No, I can't behind that.
I can partially.
All right, now, sine of 690. Where is 690?
It's like
It's,
330.
Yeah, like, guys, 690 just means I've gone 360 and then I have to keep going. Well, how far do I have to keep going? What I can do is just take that 690 and subtract 360 degrees. And when I do, I end up with the sine of 330. And since they both end up in the same place, they have the same sign of -1/2. So sine 330, sine 690, same thing. Does that make sense?
wait, how do you know it's same as 360?
If I do 690 minus 360,
Yeah.
so I ignore that first rotation, I have 330 degrees left to go. So when you have an angle that's not on the unit circle, what you can do is add or subtract a rotation. One exact rotation. What is one exact rotation in degrees? It is 360. So to turn that 690 into something on the unit circle, I need to subtract a rotation from it. And when I do, I end up with 330.
Okay.
Now, let's talk about the cosine of 3 pi. 3 pi is not on my unit circle.
Would it just be where pi is and you went around one?
So we're going to subtract 1 full rotation. What's 1 full rotation in radians? 2 pi. So I'm going to take that 3 pi and subtract that rotation, and I am at cosine of 1 pi, because 3 pi minus 2 pi is pi.
This is making sense.
So what's the cosine of pi?
-1.
-1. So, guys, to picture this, 3 pi, I would go like this. This is 3 pi. Okay? And so what we're doing is we're subtracting that first rotation so that we can see where we would end up. Okay? Where is negative 225 going to be?
At 225.
Would it be
What do we do with negative angles? We go in the opposite direction, right?
So 135?
50.
So let's see, that's 90, 180, and I have to go 45 more.
Could we just add 360 to it?
Or just add 1 full rotation to see where we are. Right on. You can always add or subtract a full rotation, whether that be 360 degrees or 2 pi. And since it's in the exact same location, I'm going to call that also -1 for the exact same reason this one was -1. They're the same angle, they're coterminal.
Wait, isn't there? Oh, never mind.
All right, do you guys mind if I add one in the margin for you? Please. There's one more I want to show you because then what I'm going to do, guys, is I'm going to leave my unit circle up on the board and let you do some of the practice on the next page. Okay? And in order for me to leave I want to show you one more thing before you get to the next page, okay? There is practice on the next page, right?
Yeah.
And that way you don't have to flip back and forth for those practice problems. Okay. I got one more. The tangent of, let's do 5 pi over 3. No, let's do 11 pi over 6.
Yeah, I'm crying.
It's going to be okay.
Would it just be -1/2?
Well, it'd be the y coordinate over the x coordinate.
Then you just leave it like that.
You're not going to leave it like that
I know.
because I said so. Okay.
This is exact though.
It is exact, but we're going to, a fraction within a fraction is like not super pleasant for Miss Meister. Okay. We're going to do 2 things to this. Do you guys see how the denominators match?
Can we get rid of it?
Let's just cancel out those denominators. And in fact, you can always just ignore the denominators for tangent. Okay. Then what you're going to do, so now that works out to -1 over the square root of 3, right? But I don't like having that square root in the bottom, so I'm going to have you guys multiply by root 3 over root 3. Now, why were we able to cancel out the denominators? Because they're the exact same thing. Look around your unit circle. When you have denominators, they're all the same thing. You'll always be able to cancel out those denominators. Okay? Oh, you remember that time I said I'm only going to do one more? I lied. I got to do one more after that. And then I promise I'm done. Okay?
She's broken.
So is the answer just,
Negative root 3 over 3.
oh, wait,
Negative square root 3 over 3 is the answer.
No.
Also exact.
okay.
All right. Now, I said one more. This one really is one more, I promise. What is the tangent of 90 degrees? Look at how sad I am.
Undefined.
You're not allowed to have a 0 in the bottom of the fraction, so this is undefined.
We multiply the 0 to get it in the top one though. We need 0.
You would have 0 times the tangent of 90 equals 1, and 0 times anything equals 0, which is what the problem is. Yeah. Whereas if I said the tangent of 180, you guys, tangent of 180 is 0 over negative 1. This is totally allowed. You can have a 0 on the top. You can't have a 0 on the bottom. All right.